In this video, we're going to talk about extension methods, which are simply methods, usually like helper methods, that can be bolted on to the side of existing types, or rather classes, even if that type is sealed, meaning that it can't be inherited from. In the past, you may have had helper methods that are intended for operation on a given type. So a formatting method, for example. This is similar in concept, but the implementation is cleaner and more elegant, and it allows for what's called a fluent style of programming. So the reason why extension methods are important is because this is how links methods like the select and the where and the sum, which we saw a couple videos ago, and the count, and those type of methods are bolted on the side of types that implement IEnumerable of type whatever. So if they implement that interface, then they automatically get these helper methods bolted on the side, even though that wasn't originally in the plan of the people who built the interface IEnumerable. So extension methods are what make links method syntax work, as we'll look at later on today and tomorrow. Alright, so let's do this. Suppose we have some code that, and we've seen this, and this is pretty easy stuff, right? Int I equals 7, and then I want to do something here. I'm going to create a static void print int I, and here we're going to do something simple like console.writeLine, whoops, writeLine, and then called print, and then we'll do that syntax. Okay, we're gonna go print I. Whoops. Let's run the application. All right, so that's pretty straightforward. But let me say this: wouldn't it be better if, first of all, that we could use this print for any object? Well, I think we could if we were to change like this to object, and we'll change this to O. Let's see if that works. Okay, that still works. So that's the first improvement we can make to it, to generalize it, as long as it implements toString, and I think almost every basic type does. But then, wouldn't it also be nice if we could call it a little bit more fluently, like this toString method here? Instead of calling print and then passing in a parameter, wouldn't it be nice if we could just go, I.toString? Well, this is exactly what you can do with extension methods. Let's change things around a little bit. First of all, I'm going to use the word this. I'm also going to change this class to be static, only because if I create an extension method, I have to have a static class. Okay, and then I think the next thing I'm going to do is comment this out, and then I'm going to do iPrint. Now let's see if that works. All right, and it does. So you might not think that this is much of an improvement just yet, but we're going to see in a moment how elegant this becomes as we add in a few wrinkles. So let me do a few other things here. I'm going to paste in some code. Which are a number of additional extension methods. Now again, I want to emphasize that the way that we create an extension method is use this keyword. It has to be static, and it has to live in a class that's static. And typically, we wouldn't put all of these, for example, in our within our static class program. We would probably create a whole separate class file to store our extension methods in, especially if they were all kind of related together. But now this allows me to do what, again, a fluent style of programming that we can do something like this. Okay, so you can see here that, first of all, I'm starting with the number 10, and I'm going to increment it. This will increase the number by 1, so that should be 11. Now it returns that number, 11, to the next in the chain, which is the bonus. So I have 11, let's take a look at bonus, and now I'm going to add 5, so that should be 16. And then I'm going to the next, and that will return the number 16, and then it goes to the next in the chain, which will be double, which just multiplies it by 2, so that should be, what, 32 now. And then we're going to call decrement, and we look at that, and that will subtract 1. So that would be, what, 31, and then we're going to print that out. Let's see if I get the right number here. Well, 30. I must have something a little bit odd in my how I decremented or incremented or whatever the case might be. But I'm pretty close. Again, that was math in my head. So I'm going to defer to the definitions that we have here. But at any rate, you can see how this can lead to a much more convenient programming style than having to, grab off the value from this method and then pass it to the next method and then pass it to the next method. And so you've got basically 6 or 8 lines of code. Additionally, I'm able to bolt this onto the side of an existing type of integer. How can I add methods to integer? Well, you can through extension methods and to any type that you want to add it to. So again, why are extension methods important to the LINQ story? Because LINQ's method syntax, which we'll look at later, relies heavily on extension methods. LINQ basically bolts onto the side of .NET by using extension methods to extend anything that implements IEnumerable of T. So there are some other LINQ extension methods specifically for other interfaces like iQueryable of T, and there might be others too that I'm not as familiar with. But at any rate, as we are building this case towards LINQ and trying to better understand the underpinnings of LINQ and how it's able to accomplish what it does so elegantly, extension methods are an important part of that. Additionally, I've seen and some of my friends use extension methods extensively to extend existing classes in the .NET framework or to applications that were built by other developers in their organization. They don't want to touch the code, so what they'll do is create an additional class file, add all their extension methods, and now they have extended the functionality without having to touch the core definition of that class and potentially break something. So it's a great way, it's a convenient way to extend an existing type. Okay, so that's it for extension methods. In the next video, we will continue on with building a case for LINQ. See you there. Thank you.